There we go. A reflection is a transformation in which a figure is reflected or flipped in a line called the line of reflection. You're going to have to identify in this lesson if things have symmetry and what the line of reflection is if it has it. Okay? So, we want to identify on these three pictures if there is symmetry. Symmetry should be easy for you to comprehend because it's like looking in a mirror, right? It reflects everything back perfectly. It can map back on itself, is what it's called. So tell whether the transformation is a reflection. If so, identify the line of reflection. Is this, the blue to red, a reflection?
Yes.
Okay, what is the line of reflection? The x-axis. The x-axis. Are the arrows reflections?
Yes.
What is the line of reflection?
Y.
Y-axis. Are the those parallelograms reflections?
No.
No. Okay. So we just have to be able to look at things and decide what reflections are going on. Okay. You can use coordinate notation to describe images of figures. What is coordinate notation again? We talked about it in last lesson. You applied coordinate notation to a lot of stuff.
The thing.
X.
Yes.
I don't know.
So it's where I have x, y, and it maps onto x plus or minus something, y plus or minus something. That's coordinate notation. Okay. With reflection, we can use coordinate notation also to describe what's going on. So, if you look at these beautiful pictures, this is the original. How do I know blue is the original? No.
Red has.
Isn't that the tick mark?
Yeah, because red has the tick marks. Good. So, if this is -2, 3, and this is 4, 1, okay, and the new mark for B is 4, -1, and the new mark for A is -2, 3, that means that I have reflection going on, yes? Because if I fold that paper, it reflects over. Okay? What is my line of reflection, my line of symmetry? Yeah, the x-axis, okay? But I also can describe this in coordinate notation. So if I multiply the y coordinates by -1, okay, then I get what happens. So sometimes when I use coordinate notation for reflection, it's going to look more like multiplication and not addition and subtraction. So addition and subtraction is going to go with transformations that slide. Okay? With reflection, the transformation is going to be multiplication. So if I look here, this is -2, this is still -2, that's 4, that's 4. That's why it's just x. Nothing happened to the x, it stayed the same. Okay? But my y's changed by being multiplied by a negative. 3 changed to -3, 1 changed to -1. So my coordinates for that is x and then -y. Okay, so for reflection, I'm going to have multiplication. Okay? Now over here, you have -4, 3, -2, -3. 4, 3, 2, -3. What do you notice is the difference between these points here? What happened? Did the x's change?
Yes.
By what?
By a positive or negative.
By a negative. They were multiplied by a negative. Did the y's change? No, so my coordinate notation for this would be -x, y.
Right.
Okay? Now, you're going to have some on your homework where it does something to both. It could do something to both, possibly, and we'll talk about that if that comes up. But just know that that's what we're looking for coordinate notation when we're talking reflection. Okay? Now, let's take a look at this. Okay. I don't want to show everything, so we're going to just do this. If I want to draw a triangle ABC with the vertices of 1, -1, 3, 2, and 4, -3, then find the coordinates of the vertices of the image after a reflection in the y-axis and draw the image. Okay? So let's say I have this graph. Remember, it's not going to be beautiful because nothing goes above 5, right? Yep. And I wanna graph the points, what are they? 1, -1, that's A. I wanna graph 3, 2, that's B. And I wanna graph 4, -3, this is C. I connect these dots, yes? And then the new image, it says you want to reflect it over the y-axis. If I reflect it over the y-axis, am I reflecting it across or up and down? Across, okay. So let's reflect it across. Where would point A go across?
Negative
-1, -1.
Beautiful, -1, -1. Where would B go across?
-3, +2.
-3, +2, good. Where does C go?
-4, -3.
-4, -3, good. -4, -3, beautiful. And now I have my reflected image. Okay, does that make sense? Okay, now, if I want to write that in coordinate notation, how do I write that in coordinate notation?
X, Y, arrow, -X, Y.
Good, X, Y, arrow, and what we changed was the X, correct? -X, Y, Y stayed the same. Now, I'm going to add something to this. What happens if I want to reflect this original image over the X-axis? What happens to point A? Where does point A go?
Down.
No, I said over the X-axis.
Oh,
It goes up to what? To what? 1, 1. This reflects
1.
up because this is the X-axis. So this becomes point A. Okay? What happens to point B?
it goes up to.
No.
Does it go up? Point C is gonna be where point B is.
What's point C gonna be?
Where point B is.
4.3? Okay. So we're gonna do 4.3 for C. But where does B go? If I'm reflecting over the X-axis, that means I fold it at the X-axis. So where would B end up if I fold that piece of paper down? If I fold this, where does B go? Down. So it's gonna go down to 3, -2. Uh-huh. So it's gonna go to 3, -2. So listen, if your image is splitting the X or Y axes, the points above it reflect down, the points below it reflect up. If it's splitting the Y axes, if I'm reflecting over the Y axes and some are over here and some over here, they flip sides, okay? So I just wanted you to notice that because that can be tricky in our minds,
They're
okay?
gonna be on our homework.
It can be on your homework possibly. Craig, you can do it, I know you can. So just to double check what we did, everything here is beautiful, okay? Now talk to me about this. Is there a way to write that in coordinate notation, the green one?
X, Y,
What
arrow,
happens?
-X, -Y.
So, yes. So -X, -Y. Good. Well, wait, is it -X? No, because this,
X -Y?
it should be X, -Y, because this, the X's always stay the same. X is still 1, X is still 3, X is still 4, so it's X -Y. Okay? Now, let's talk line symmetry. Okay, a figure has line symmetry if a line called the line of symmetry divides the figure into two parts that are reflections of each other in the line. A figure may have more than one line of symmetry. How many lines of symmetry does a circle have? As many as you want. A circle can be divided anywhere in half, okay? How many lines of symmetry does a square have?
2?
4.
4.
Oh, yeah.
Because I can have diagonal lines of symmetry. So if I have this square, right, pretend it's a perfect square. I can go here, I can go here, I can go across, I can go down, yes? Okay? So when you're doing lines of symmetry, if you need to, draw it out. It might be easier for you to see. So here are some examples of flags. When you're dealing with flags, you have to take into consideration the images that are printed on them as well for line symmetry, not just the shape of the flag. Okay, so this Colorado flag has one line of symmetry because this C and everything can be broken down and flipped over on itself and it maps on itself. Okay, meaning the image is exactly the same when I fold it. The Puerto Rican flag, however, cannot because this star is a 5-pointed star, and when I fold it down, that point's not going to map on anything. If I fold it this way, there's no other star on the other side. Okay? The New Mexico flag works out perfect because the cross has a line of symmetry. So it has a horizontal line of symmetry and a vertical. Yes,
Wouldn't it
sir.
be-
Can you do that diagonally also?
Yeah, that's what I was gonna say.
Yes. You can go diagonally on that also. Yes. Okay. How many lines of symmetry do these figures have? How many lines of symmetry does this triangle have?
One.
One. Where at?
From the tip
Down
of the
the middle.
point.
It would be down this point, right? Like this.
Yeah.
Okay. Does this object have a line of symmetry?
No.
No. Can't do it. What about here?
Yeah.
4.
1, 2, 3, 4, correct? Okay, cool. My eraser's like slowly acting. Okay, now let's see here. I think that is it. It is. We are done. I will give you some homework to do. Beautiful.
You should give us like